Well, good afternoon. I'm Jennifer Fogarty from NASA Johnson Space Center. I'm going to introduce you to our panel. We have 4 panelists with us today to talk about the data challenges they've run, the kind of the methods behind them, the madness, some of the results they have, and kind of cultural aspects of how they did their implementation. So I hope there's something there for everyone. My role as facilitator today is going to help to connect the dots between the speakers a bit, give you some context for those of you who are new to this type of work. I'm going to allow each speaker to use up their time to introduce their material and a bit of discussion, then open it up to the audience, because this is really about you interacting and learning from them. So first up, we have Jason Crusan, who, as you might know by now, is the director of NASA's Center of Excellence for Collaborative Innovation. He's kind of opened the floodgates today, provided his email address, and asked to be overwhelmed. So have at it. Jason, of course, in addition to being director of the COECI, is also running the NASA Tournament Lab. So that means not only does he go out and talk about this type of work, but he actually does it. So he's going to present some interesting examples of that work for you now.
Great. So I think I can talk from down here. That's okay. So what I'm going to cover a little bit on is our efforts on our NASA Tournament Lab. So NASA Tournament Lab was started almost a year and a half ago at this point. And we were formed to look at solving hard software and algorithmic problems at NASA, specific to some of our missions. So we had 2 functions that we wanted to be able to do, which is first off and foremost, actually provide high quality software solutions to actual real mission requirements that we have. And in addition to that, we also have a secondary effort where we are working with Harvard University and the academics to advance the actual science of running tournaments as well. And I can't seem to get the slides to advance, so I'll just talk to some of these at this point. If we go on one more slide, if you guys manually do it, that might be better. So what we're doing with NASA Tournament Lab is we're looking at different types of software solutions that we need, everything from image analysis to motion detection to modeling and prediction type software. How do we actually drive and do challenges even for user interface design for some of our software systems? We all do this under the auspices of running challenges to get the real solutions, but also to learn from them. So our Harvard folks help us drive and design experiments in order to figure out what are the drivers to how do we run a competition, what makes people want to participate, what are the incentive structures, cash versus non-monetary incentives we have, how do you do signaling effects or teaming arrangements, how do those affect the actual outcome, and Professor Karim Lakhani and his colleagues are looking at that for us. And if we go on to the next slide. So we started with algorithmic challenges. So those complex, hard processing problems or optimization problems that we have, and how to get at those. And I guess it's best to dive into one of those. So on the next slide. Our first challenge that we did was related to our pipeline threat recognition. So NASA actually does a lot of work under partnership with other government agencies, and one of those agencies that we work with is the Pipeline Safety Research Council. And one of the areas that we work with them on is image analysis. And how do we look at aerial photography and satellite imagery in this case to analyze whether there's a threat on a pipeline, be it digging equipment, construction equipment, or some other means. And they have a large amount of data that they have to process, and they were looking for more automated ways to do that. If we go on to the next slide. So this is a sample of a couple images that is pretty typical to what they have. These are 100 pixel by 100 pixel tiles, and yet one of their goals was to figure out which of these tiles has a vehicle in it, and define a vehicle by anything that could move, be it a cart, be it a four-wheeler, be it a truck or digging equipment, or anything that could be possibly mobile in the picture that is man-made, that could get close to a pipeline and cause damage to it. If we go on to the next slide, it's getting a little more outcome. So we ran a competition for folks to analyze the images and tell us if there's a vehicle present in the image or not. So pretty simple yes, no kind of question. Obviously we wanted to maximize the success rate and minimize the failure rates. We had nearly 1,500 people register in a 3-week time, and over 550 code solutions submitted in that short period of time. So people ask, well, what was the incentive? In this case, it was a small amount of monetary award in the order of $20,000. What was interesting here was not so much that we found a solution, because we figured we would be able to find an image processing solution. There's a lot of people in this area. But the top 5 solutions that came in, 3 of them had never been published in peer literature before, or were completely unaware. We were unaware of that technique in order to analyze the images. So they're extremely novel. The other side of it was we got some interesting questions. So there's a lot of game theory that comes into these challenges as well. In the middle of the competition, people were asking, where are these pictures from? And we didn't actually know at that time, because we had just pulled a random data set out. But come to find out, the reason why they were asking afterwards is if you actually know the geolocation of a data, you can actually correlate it to car sales and make a histogram of the image that you see. And the colors that appear in vehicles do not appear in nature. And you can get 75% accuracy on the image processing by absolutely not even looking at the image at all, except for the histogram. So it was an interesting approach of kind of big data fusion that was coming to play in that. If we go on to the next one, I want to give you one more example. So NASA ran, we have obviously our active Apollo images that we have, and also a new data set growing from our Lunar Reconnaissance Orbiter. So we have all the science data, literally tens of terabytes and growing every day of data, and the scientists want to be able to analyze the data, figure out a rate of crater impacts and types of impacts that they have. And we actually put a large set of data out, over 200,000 images, through a project called MoonZoo, and we had the public at large actually go off and click and categorize all those images. And we had a great response rate, lots of participation on that. A lot of people came in and helped us with those 200,000 images that we put out there. The only problem with that is we actually have over 2 billion images, and it grows every single day by literally almost a terabyte of data a week. So how do you actually, you won't get people to click on 2 billion images, so how do we actually create an algorithm to do basically what we had the folks do for us through the clicking? If you click on the next slide, speaking of clicking on it, so in a 2-week-long time for $10,000, we had over 1,200, nearly 1,200 registrants, 310 actual unique submissions of actually code. Interesting enough, that doesn't equate to 310 people. On average, the average competitor in this challenge put in over 8.5 submissions. So they lots of kind of points on goal trying to improve their algorithm. And so in a very short period of time, in 2 weeks, we had an algorithm that was about 85% accurate for about $10,000. So now what we're doing is taking those top solutions and internalizing them to figure out what's the next step. Do we actually combine all those algorithms and get from an 85 to a nearly 100% solution? But in this case, we had no code written from day one. So in a matter of 3 weeks' time, we now got our code, a very strong, robust code base to start from for our project. And we may in turn go back out external again to finish out this algorithm. But in a very short period of time, we got to a pretty good state that we wouldn't have been able to normally get to for $10,000. So I just wanted to give you some real-world examples to kick it off.
Well, thank you, Jason. Some interesting topics maybe we could dive a little bit deeper on in your challenges. One, just a point of discussion for the algorithm and big data. Oftentimes you can run an algorithm challenge, and I think Jason's first example was, even though it was a lot of data, it was a well-defined set, and you were looking for something specific and needed code written to go extract that from the data source. In the second example, there's just a huge amount of data, and you're trying to fish through this problem of signal-to-noise ratio, which I think you're going to see repeated through the next couple speakers, where it's just this massive amount of information, and how do you actually find meaningful stuff from it? So there's kind of 2 layers to those types of challenges. Going back to your model, so in our work at Johnson Space Center with Jeff Davis and Cynthia Rando, we've used the Procurement Authority, I'm going to tie it back to an earlier conversation about legal, to run our challenges. Jason used a bit of a different model, which I think is interesting for other agencies to consider, partnering with academia, which then partnered with a platform. Do you want to give any advice or kind of your lessons learned about your model?
Yeah, so it's one thing, there's a lot of platform providers that are out there. There's probably several in the room here today. But what we wanted to do as a government agency is we didn't want to bias ourselves to one platform and one platform owner only. So we actually purposely sought out kind of our prime contractor in this case to be an academic institution that didn't actually have a bias to one platform or another, but rather had a bias towards empirical academic research. And that's enabled us to make a lot smarter decisions that aren't based on business drivers at all, but rather that kind of building the empirical knowledge of how this actually works. So in a lot of ways, it's helped us make us much better buyers at the end. And they've provided a lot of resources from the academic side in addition. And then obviously with the platform providers, a lot of them are really, really good, and they can help you in the implementation side. So that kind of joint government, academia, and private sector all working together, if in the right mix for us, was the right answer, and it got us pretty good solutions today.
So one of the interesting parts of the academic element of this collaboration is looking at various types of incentives, monetary and non-monetary. And obviously we're all interested in what is going to drive people to participate in these challenges and then return quality solutions. So you want to give any comment to the various types of incentives that you've seen become like a valuable lever or tool to use? Yeah,
so I can't stress enough, money is not everything on challenges. And just because you have $1 million prize doesn't mean you'll get $1 million solutions. And you actually you have to figure out how you decompose your problem and size your prize purse, your incentive purse, to justify the amount of time that somebody is going to have to put into this. One of the parts in the academic research that nearly 70% of the time people are applying knowledge they already have, not actually having to create new knowledge. So the amount of time you think it takes to solve something, you may be completely off on. So how you size that incentive. We've had a lot of success with non-monetary awards as well. We've everything from just people having non-monetary invites to come see a launch. Now, we're NASA, so people do want to come see launches, and that's a different driver that we have. But I would challenge a lot of your other agencies that you have some neat things that also could be provided as non-monetary incentives that could also help drive participation. Even T-shirts and those kind of things. The platform providers, it's amazing how many solutions we've gotten for $1,000 in a T-shirt. So.
Yes, T-shirts can be a very powerful tool. We also, during our work with external crowdsourcing, found a real value in the NASA brand and how that attracted people, and them wanting this altruistic sense of contributing to the NASA mission. And I think other agencies would find that same element available to them. Just teasing it apart and understanding what role it plays takes a little bit of time and probably some people with experience to help you balance what that means and how do you use it. But again, money is not always the biggest driver, and actually you do see that when you put too much money on a challenge, it signals the wrong thing. You could definitely signal that a challenge is way more complex than what you intend by putting a big price tag on it. So there's a lot of discussion there to have, and a lot of thought that should be put into the award. And we're going to touch on problem deconstruction a bit more along the way, because it's another critical element that we want to emphasize. So any other comments you want to make?
No, just to stress that one last comment you made is if you think about it in the terms of a competitor, if you look at a prize that's a $200,000 or $1 million prize, as a competitor walking in, do you know if your thoughts are worth $1 million? Could that actually be an obstacle versus, well, that challenge is only $5,000, so it can't be that hard. I can actually contribute to that versus contribute to $1 million idea. So the number one conversation we have a lot of agencies that come in and say, well, I got $800,000 or $1 million to run a challenge. I said, well, that's great. You have plenty of budget. How many other challenges do you want to run? Because that's actually way too much. And try to figure out that right balance of problem decomposition to sizing of the prize purse to drive the maximum performance.
And some of these are the nuances of doing this work, and we don't have all of the answers, and there's no nice script to follow and recipe to follow. It can be a bit unique while we learn these things. And again, it's just a lot of discussion, whether it be with COE/CI people or platform people who are experts in this. But it's worth the discussion and just being aware that these are elements that should be considered and kind of debated, and not just, you know, some tag put on it that you think is the right value, because that's what the last kind of challenge you did. So there's a unique application. So we're going to move on to our next speaker. This is Mr. Greg Hanson. He's the Chief Operating Officer and GM from Tree.com. Greg and I had a chance to catch up before the panel, and really with his, it was an interesting discussion on signal-to-noise ratio, and he has an interesting application where they ran a challenge trying to do matching customers with agents for the highest productivity that would also, in the end, benefit his business. And I've also asked him to touch on metrics a bit, so I'm going to open it up for Greg.
This is applies to the sexy world of real estate and internet marketing. This is a pure commercial enterprise. So you're probably familiar with LendingTree, which is the biggest of our brands. Realestate.com was the business unit we ran this competition for. And if you are familiar with any of the commercials of LendingTree where banks compete, you win, at least that's what we like to say. It's true of all of our verticals, of which you probably are less familiar: real estate, insurance, a little bit of healthcare, automotive, even home improvement. And the big commercial problem for us is from the millions and actually billions of impressions we serve on the internet, distilling down through a series of steps a consumer with real intent to make a transaction with somebody in our network. And the consumer is usually looking to be paired with one or more service providers in mortgage, in actually clinical trials, insurance providers, home improvement professionals, auto dealers. This is kind of a broad problem that we solve commercially. When the consumer is paired with those service providers, that's the point at which we make money. We make money right at that moment, but the amount of money we make is determined by the amount of money our service providers make themselves. So they are constantly evaluating the intent of our consumers to utilize their service. So in the short run, we can play games and send through consumers who maybe are a little less qualified, or we can kind of consistently work the angle that we need to produce the most qualified consumers over and over and over a long period of time. And there's a number of business metrics that prove out we are doing a good job at that. So from the billions of impressions we serve on the internet to the hundreds of thousands of consumers we transmit to our networks each month, to the tens of thousands of transactions that happen among our networks every month, you're talking about billions of dollars of commercial transactions that are created through our advertising. And this is a problem. This problem in real estate has to do with matching a consumer looking to buy or sell a home with a real estate agent who will help them do that. The real estate agent makes money as a function of the home price. And you know, there's a number of scenarios under which that might not happen, but I'll give you some scale factors. We ran a project, this competition, for a little less than $10,000, and we gave out 4 second place awards and 1 first place award. We had 165 competitors who entered 1.6 or 1.7 solutions each. And what we gave them was 2 data sets, one to run the test on and then one as a training set to kind of prove out. And what these data sets look like are some consumer attributes, geographic attributes, time of year attributes, marketing sources, all kinds of things. But what we really need is a way to predict the best agent to pair the consumer with. Now, you get into very small number statistics very, very quickly, because your average real estate agent will close only a couple homes per year. So the data on the agent side is thready at best. On the consumer side, we're loaded up to an extreme extent. So that kind of magic pairing, though, the revenue of 1 extra home closed is more valuable than the entire competition. So like, as a commercial way of exploring leverage in our business, this is a phenomenally efficient way to get at algorithms. We had 5 kind of near winners. One we picked as the best. We thought it was the most sort of efficient to implement. We implemented it, and what we saw was a rise in the close rate per agent. So that would mean if we send 100 consumers to an agent, the number of homes that they transact over a year or 2 years increases. Now, it's relatively, it's part of our underlying business to track that sort of metric very, very carefully. So we were in a particularly good position to be able to evaluate that the competition mattered. We have run other competitions where we have generated models that tell us certain variables are predictive, but they are not actionable variables. And this is where the signal noise and sort of business applicability comes in. In the case of matching a consumer with a real estate agent, you know, they have to fit the geography or else they're not a match. They might be a nice person, but it just doesn't matter. Some agents need to get enough consumers to pay their own rent or they'll just drop out of the business. So there's sort of minimum thresholds and things like that. On the consumer side, we have data that we can't always collect. It might be predictive, but we can't force the consumer to always give it to us. So that would be a case where there's elements in the data set that are highly predictive if available, but if not available, it doesn't tell us anything. So then you have to go down the next layer. And so the winner of our competition kind of solved that problem for us. And we had 2 leads in our business. One was a head of engineering, so software engineering, and the other was a lead architect who happened to have an advanced math background. And it turns out she was able to determine the solutions were in fact buildable. He was able to determine what they actually meant, and that's kind of how we went about it.
So thinking through this problem, my mind goes toward trying to abstract what you described for your purposes and trying to imagine it for a NASA purpose or, a DoD purpose or a DHS purpose, and think about that matching concept and how do you find those critical, going back to signal to noise, the meaningful signals that allow the match to be a productive one, and then you get validation through the implementation. So you said, I guess, could you describe a little bit more, because this was also a point this morning about that Kristen made about the legacy part. And in our work, we've really pushed for people thinking through, imagining success and what would the implementation be, because oftentimes that reflects back on what you're really asking for and what's realistic or what's possible. So could you describe a little bit more about how you actually put it into play? It obviously resulted, like you said, in more deals being closed, so that showed value. But in your organization, we touched a little bit on this because that's where maybe some of the cultural barriers come into play. You have everybody on the team on board, you have your stakeholders buying in, but there's a much larger group that has to accept the implementation. So you want to touch on that as well?
So in the real estate, this would apply to any vertical, but there's kind of, industry wonks in all of these businesses who sort of know how things are done. So on the real estate agent side, the concept that an algorithm could tell anyone that they were going to be able to close the deal or not is anathema. The agents are kind of very ego-driven. On the engineering side, all the engineers, at least in our company, believe they can solve any problem if given enough time, which I think is true. We just don't have that much time. So kind of carving away space to help people understand that they own the solutions that we bring in from third parties, and they can guide and augment and improve upon these things. And we tend to talk about it like force augmentation. It's basically a way to get more out of the business without having to do everything. And in a commercial enterprise, that's an effective message. I think we typically have a not built here problem in the sense that our engineering teams will make obscenely complex requirements for outsourced projects, and like we call them Death Stars, like they're just so incredibly complicated and huge that nobody could ever effectively build them and they'll never get rolled out. And in fact, that's happened many times. And that's sort of a way of saying, I told you so. And in this particular case, we ran a 2-week competition for an incredibly narrowly defined problem that was going to replace a very primitive algorithm that everybody knew was primitive. It happens at one point in the process where you've got the consumer data and the system is seeking through a list of agents that are available at that moment for the best match. It was relatively simple, and nobody was happy with the current solution. So we kind of put ourselves in a good position to implement something foreign, for lack of a better word.
So I was wondering if we were going to be able to find that bridge to lendingtree.com. So let's see. I don't really work with any egos at NASA. The engineers, given enough time, I don't know if they could build anything. So you start to see, like, we go to different courses and try to learn from industry, and really you have to really engage and think about what elements of it do we have in common, because it has been a struggle, even, you know, with all we've been through the past 5 years of doing this, of kind of pulling out those nuggets from what industry has done or what the thought leaders have done and what they've implemented, and how can we use it and not reinvent the wheel. So I really appreciate your story, and I think it's an important one for us to think through. What is it we're targeting? Who are we trying to match with? What are the best matches? How do we scrutinize the results of these things? And then culturally, how do we really start to educate our folks about the value of it? And you know, you're going to have a spectrum of the early adopters, the people who see the value in it or want to be on up front with everything. You're going to have the middle of the road. You kind of have to prove it to them. And then there's folks, you're just, you know, it may have to be that top-down mandate. This is the new tool we're using because the old one's gone now. So there's a spectrum of things. So really appreciate your story, and hopefully the audience will come back with some more questions at the end. So moving on to our third panelist, we're very lucky to have Balaji Krishnapuram, working on that. He's a senior staff scientist from Seimens Medical Solutions. He's going to be talking to us about the KDD Cup 2008, which he subsequently told me happens every year. This is actually a fascinating story about computer-aided detection for earlier diagnosis of breast cancer from X-ray images. And you know what I thought was really interesting reading through your slides, not to preempt him, was we have a similar issue with one of our algorithms that I think was presented at the last session about an unusually high false positive rate. And that this may actually talk to why you need subsequent challenges. Like, you're going to run a challenge, you're going to find a solution, you're going to implement it, and then it's going to need to be tweaked. There's going to need to be some efficiency. And I think that was brought up earlier about some of the real defined algorithms. You can start with a big data issue you need resolved, you know, targeting the signal to noise issue. You're going to get a solution, then you're going to figure out, now I got to run an optimization challenge. So there is a process here, and it's not, you don't just run one and end. I mean, you have to think about it kind of in a continuum or in a project-like fashion. So Balaji, I'm going to hand it over to you, and you have a couple of slides to go through with us.
Sure. So I should start this with a couple of quick points. First is a disclaimer that I am not speaking for my company. The slides here really represent my view as an individual. And in fact, I speak more for a research community that I've been a part of. I've been organizing this annual conference called the Association for Computing Machinery's Special Interest Group on Knowledge Discovery and Data Mining. It's basically the largest data mining research conference in the world, a couple of thousand people now, started in 1990 or so. This is the place to go if you want to talk about big data, stuff like that. And over the last 20 years, we've been running a competition called KDD Cup, the Knowledge Discovery and Data Mining competition. It's an annual event, and we really do this to build a community, to rejuvenate our community by posing new questions, new practical questions, which will encourage us to think about new theoretical models, new abstract paradigms that will enable these problems to be solved. And as a result of doing this type of work, we also hope that several of these will get translated back and start several startups. So in fact, this conference is very interesting because it has led to several dozen, maybe 100 startups, several dozen things transitioning and becoming products. So there's this tight interplay between the academic research community, which is about 50% of our audience, and the industry. So that's why you'll find a lot of support from people like Google, Yahoo, Microsoft, Seimens at this conference. The second point I wanted to make right at the beginning is that this is really a collaboration. When I ran this cup in 2008, it was really a collaboration with couple of other folks. One was Bharat Rao from Seimens. Another was a grad student of mine at that time. Oksana Yaknenko is now at Google. We can go on to the next slide. So maybe one more. Yeah. So let's take one specific example of KDD Cup in 2008 and make a few. I'll only talk about one competition here to make the points more concrete. Why bother detecting with an algorithm for detecting breast cancer from X-ray images? Turns out there are a few problem characteristics. Out of 1,000 women, so in the US, women over age of 40 get annual mammogram screening. So you just go for an X-ray and they try to find out if you have breast cancer. Turns out for about 1,000 women that you screen in a year, something like 100 to 150 to maybe 200, depending on the location and where you go, will get recalled for further examination. So they don't know if something is there, but they're suspicious. Of them, only about 5 to 15 will actually end up having cancer. So this is a problem which is quite difficult. And of the 5 to 15 who have cancer, let's say it's 5, only about 3.5 will actually be detected. So 1.5 cancers will be missed. So you're trying to find a needle in a haystack, and that's the reality of the problem. And this is not uncommon in many different situations. So for example, you try to recommend things on the internet. You're a bookseller. Amazon wants to recommend you things. Now there are millions of books. I'm really not interested in the vast majority of them. In the problem of recommending advertisements to users, this is a common endemic problem, the one that you alluded to earlier. So the problem occurs here as well, and there are systemic solutions across domains that will translate. Nevertheless, so in this particular case, there was commercial products which tried to help radiologists read these images more accurately. Turns out, so radiologists in certain types of cancers miss something like 30% of the breast cancers, which is ridiculous, right? But if you have 2 radiologists reading the same image independently, turns out they go down to missing only about 10% of the cancers. So the information is there. It's not always easily tracked. Why? Not because it's difficult, but because they're looking at 1,000 images to find 5, right? So it's normal. I mean, you're going to be overworked. So CAD was introduced as a second reader paradigm to make sure that you didn't accidentally overlook things. Now, since the 90s, several nice things happened. The rate of detection of cancer first spiked up and then came back down to the same level of cancers that are incidence rate in the population. But you are finding cancers at an earlier and earlier stage. So it improves survival. It has a lot of good outcomes. However, there were 2 problems. While you reduce the number of people who got missed with cancers, you pushed up the recall rates. That's dangerous because you're going to recall a lot more women. Second problem is radiologists now spend a whole bunch more time. They're already pressed for time. They're not very fond of spending more time with a computer on doing exactly what they were doing earlier. So you got to find ways to reduce the time that they spend on this. And from a commercial side, our company was a late entrant to this market, this particular market. In other cases, we were the first to market. And we wanted to find something that was a substantial improvement over the current state of the art from the market leader at the time. So we wanted to find something that would potentially change the paradigm. Can I have a CAD program that dismisses, say, 50, 60, 70% of the women and says, doctor, you don't really need to waste your time reading these images. I'm very, very sure they're absolutely normal. Just look at these 30% of the images. And voila, you've saved him 6 hours of his time. Can you do it in a different way and try to reduce the false negatives? So try to reduce the mistakes, the missed cancers. And these are 2 different problems. So we try to address these problems internally in the company. We've got, to my mind, a very, very strong research group. We've hired only probably the strongest data mining and machine learning people in this industry, this community. I've written several books, won Best Paper Award, so I consider myself an expert in this area with some Best Paper Awards in this very specific area. But I wanted to find out how much can we really improve things. And I didn't have an endless budget. If I try to build this thing where the CAD is a first reader, it will take me several years, 3, 4, 5 years, and then the process and expense of going through an FDA trial. all to find out that the market may not even be willing to take this up. So I wanted to reduce the cost for doing something like this without the huge investments. Maybe we can go to the next slide. Okay, maybe I can, yeah. So in this competition, we ended up providing about 1,700 patients worth of data, which may not sound like much in this room, but it's actually a lot. It's a really expensive thing because you got to get patient consent, you got to anonymize the data, there's all kinds of issues about healthcare data, and another 1,000 odd patients for held out data to see how well these competitors really worked, and which is the best algorithm, etc. And we ran 2 different competitions. And on the image, I've basically shown that there is really typically 3 steps to this type of work. The first step is identifying suspicious regions, things like finding objects which have a sharp boundary, or things that look like a mass, or things that look circular. Various simple things can be done to just identify suspicious regions. Each region being characterized by a bunch of mathematical descriptors, shape, size, texture, what have you, thousands of them. And then each of them is then thrown through a classifier which determines, yes, this is actually important enough that I should show it to a doctor, or the vast majority, 99.9%, are actually not worth showing a doctor. Now, our competition wanted to focus on the last one, primarily because we were restricted in the amount of time and effort we could ask our participants to spend on this. So we spent something like 4 months in the competition itself. And I abstracted out all the details of the domain, so the medical knowledge, the image processing aspects, so that they can focus on the core mathematically abstracted problem, which can now be solved by scientists from completely different domains. People who've never looked at a medical image, people who have no experience with computer vision, people who have probably not even a data mining background. They can come in and throw their favorite mathematical algorithms and modeling and try to push this up. You can go to the next page. A quick summary of the results. We were actually prohibited by our company from actually providing any prize money. This has varied substantially over the years in KDD. There were initially, in the 90s when we started, we had maybe $1,000 to $5,000 prizes. Some years it's completely zero because of Seimens, Oxley, and other compliance issues. So Seimens is officially prohibited from paying any hospital any money, even if it were for a prize, because it could be construed to be some way influencing the purchase decision of Seimens medical equipment. So for various legal reasons, I was not allowed to provide any money. However, we had over 700 registered users from over 30 countries. So the number of participants was quite phenomenally large, more than I had actually anticipated. And the marketing was only through mailing lists for the global research community. So I would just send it out to the KD Nuggets group, which is all the data mining researchers in the world, some computer vision research communities in imaging, things that are on Google groups, basic things like that. And no real special effort to advertising the event itself. Post-event, KDD does a very good job of PR. So every year we would have New York Times, The Economist, Wall Street Journal coming to the conference. So the winners would actually get a lot of recognition. They also get job offers, stuff like that, which actually makes it interesting. One of the key results was that the participants disclosed many new ideas at the KDD workshop. So while we consider ourselves to be the leading data mining research group in this medical industry, I was really surprised by the types of solutions that came up, the ingenuity and complete left field ideas that came up in this competition. I don't know if there's another slide or if it's the last one. Perhaps. Okay, so maybe one more button, please. The 2 competitions, the first competition we got about 240 submissions. Here the challenge was, can I reduce the number of cancers that a doctor misses? The short summary is the best results were as good as a leading company in this space. Imagine 4 months of work competing against 15 years of commercial activity from the leading company. But the vast majority of submissions were quite lousy. I didn't care. I just wanted to see the good results. And this is typical over the last 20 years, we've seen essentially the same sort of a result. Second challenge was even more interesting because this is not what the FDA would permit. This has never been done. There's no other product like this. Can I actually dismiss the vast majority of patients with absolute confidence that they have no cancer? So doctor, you just only have to look at these 1/3 of your patients. Turns out you can. And I didn't know this. I didn't want to spend a few $1 million building this ahead of time and then figuring out, hey, it didn't work. I just wasted a bunch of money, or it worked and I cannot actually make a product out of it because the FDA wouldn't permit it. Turned out that one of the teams could actually do this. And there were 2 others which did it with much lesser accuracy. There's a very sharp drop-off between the top teams and the run-of-the-mill. And you'll see that repeatedly. There's a power law distribution in these kinds of competitions. So I don't know if there's any other slides. If not, I just wanted to give a few key takeaway stuff that you can use in your work in the government when you run competitions. So the first, can you press the button one more time, please? Okay, it's gone. So the first key takeaway was pushbacks from the organization. So how are you going to sell it to the people doing this work? I ran a research group, and basically my function is to have a bunch of people, smartest scientists, hire the smartest scientists, pay them good money to build new products and new technology and demonstrate their feasibility. Now you're telling these same people, hey, you don't need to go and build the algorithm. I'm going to just get a bunch of smart guys to think about the problem. There's a lot of threat to these people. Now, the way we addressed this and solved this was really twofold. Initially, it was quite problematic. The first learning was that once they saw the results, they saw that people came up with completely new ideas, did things that they didn't even think was possible, that the things would not work. The pushback went away. So they were really interested. And we were able to take some of the key algorithmic ideas that were presented at the workshop. We organized an international research workshop immediately following the competition where the participants could present the results. And the learnings were shared. And the participants were delighted to share things. They wanted to have an impact, even if it was for free. And this changed the attitude of the group. The second thing, which is even more important, which is, I think, critical, is to be able to redesign the job itself in a very fundamental way. My job as a scientist is not necessarily to come up with the best mathematical optimization algorithm. It is a detail. It's something that I have to do, and I'll do it pretty well. I'm sure I'll be one of the top few people, but maybe not the best. But really, my job is to come up with a problem, to define a really challenging problem, but to make the problem solvable. I don't remember who said this, but every model is an approximation. Every statistical model, every mathematical model is an approximation, which takes something that is very, very complicated and simplifies it in certain ways so that it can be solved. So it's a lie, but it's a lie which points you in the direction of the truth. And you can make arbitrary levels of simplifications, and you can slowly relax these simplifications over time. So my real task as a scientist is to pose the right question, pose it in a way to abstract away the things that don't matter, and pose it in a way that we can open it up to many, many different people thinking about it from many communities. So thinking about the problem, thinking about what is important about it, and posing it in a way that can be solved is really the most impressive thing that you can do, because then you're going to encourage a lot of people to work on this problem for you. So those are the papers that have 1,000 citations. The papers where I actually won Best Paper Awards because I did something cool, I have maybe 50 citations. The things where I opened it up and posed a new question which many people tried to solve have several hundred citations. That is a key takeaway point. Second, how do you sell this to your management? How do you get management to buy into something like this? Here we try to do it because there's 2 values to Seimens. One is we were able to get completely new ideas, but the more important thing is there's a clear business driver. We were able to evaluate the feasibility of a solution to a new problem that nobody had solved, that we didn't know whether it's solvable or not, at no cost, well, at minimal running costs. Third, we were able to consider the problem from a different perspective, which a lot of these other guys brought in, which is really that it's not just this particular problem here. There are actually many other industries which share certain common problem characteristics which can be leveraged. The problem of personalization addresses the issues of finding the needle in the haystack. So Amazon wants to make personalized recommendations of the books I will find interesting. In healthcare, you have the problem of personalizing treatments for patients who have cancer. So instead of just giving all non-small cell lung cancer patients with stage T3 node negative without metastasis the same treatments, you want to change the treatment and tune it to the very specific individual in front of you. How are you going to do this when you have to have infinite amount of data to do this specifically for every patient? How are you going to make ads recommendations for each patient specifically? Turns out the math behind all of this is actually exchangeable. There's a lot of deep insights from techniques such as multitask learning, inductive transfer, which allow you to exploit the simple notion that a person who learns to ride a bicycle can transfer much of the knowledge to reduce the time that it takes him to learn to ride a motorcycle, because he knows about traffic science, he knows about balance, he knows about turning. The same idea can then be put on solid mathematical footing and exploited across different industries. These cross-fertilization of ideas is key, and that can be a key way to sell it to your organization as well. I'll leave it at this. There's many other things that we can talk about, but I'll just take questions.
For sure. Thank you, Balaji. A couple key points in addition to the ones Balaji was just expanding on was the point he made about diverse solver networks and how you want this breadth of eyes on your problem to give you a better shot at getting those answers to that in the far right tail. So I encourage you to come up during the network break and follow up with each one of our speakers. So I want to give Jonathan Gluck his due time, because I think there's some collaborations. If you notice, Jason had the one about pipeline imaging, Balaji's talking about breast cancer, the National Cancer Institute is running challenges about identifying lung cancer. That there's probably some underlying solution that could help every one of those, because at the foundation it's identifying what you want to see in an image. Now, the tie between Balaji and Jonathan Gluck, who's from the Heritage Provider Network and going to discuss with us the Heritage Health Prize, is that if you can identify things earlier, get people the care they need, get them into preventive care, get compliance up, you can reduce time in hospital and costs. And they have a challenge right now that's open and been running since Monday, April 4th, and it will not close until Wednesday, April 3rd of 2013. So you have a chance to go home and ponder really cool solutions or find groups of people to work with. But I'm going to let Jonathan tell us more about the Heritage Health Prize. And it looks like Balaji's got one more.
On behalf of the knowledge discovery data mining research community, if any of you have large data sets, if you have problems you'd like us to solve, this research community just exists to get our hands on data and to try out cool new things. So if you have any problems that are really interesting, you'd like to have the top machine learning experts and data mining experts solve it, please come and talk to me or send me an email. It's just my first name dot last name @gmail.com. Thank you.
Thank you. And Jonathan, thank you for being patient.
Thank you. My name is Jonathan Gluck, and I'm at Heritage Provider Network. To give you a little bit of an understanding of who we are and why we created the challenge we did, Heritage Provider Network is what is called a full-risk integrated medical organization, and we're located in Southern California, Arizona, and New York. As a full-risk integrated organization, we take risk for all of the patient population that we manage. So if patients incur care costs, we have to pay for the costs. So in addition to obviously worrying about the quality of the care we provide, we are a doctor's organization, we also worry about the cost of the care that's provided, and specifically the ability to avoid the unnecessary care that is a big cost driver in the healthcare system. We're also, for those of you who may be familiar with healthcare, we're one of the pioneer ACOs. I'm sure you've heard a lot of conversation around the ACO model, and this will become particularly important in the ACO model, where you're dealing with fee-for-service population that is not typically as used to turning to others for their care protocols. So the problem we were trying to solve was essentially to reduce healthcare costs. As we know, 18% of GDP today is spent on healthcare costs. It's projected to rise, I think it's 30% to 30% of GDP by 2050 if we don't change something. And we do also know that we spend approximately $40 billion a year on unnecessary hospitalization costs. That would be costs associated with someone going to the hospital when that care could have been provided in a far less expensive setting. So we decided to run a challenge to see if we could predict who would go to the hospital during the year, and then from that population that was predicted to go to the hospital, determine who were the people who would be there unnecessarily, try to provide that preventive care to keep them out of the hospital and avoid the costs associated with the hospitalization. Aside from saving the costs associated with the hospitalization, it's a pretty basic premise that hospitals are not particularly great places to be unless you really need to be in a hospital. So aside from saving the money, it would also wind up keeping people healthier. So now, why did we choose to do a prize to solve this problem? Well, one reason, not the primary reason, was the return on investment. As a privately held company, if we can reduce the cost associated with the healthcare, we would save money. The preventive care that's provided outside the hospital setting is actually much less cheap to provide, or much less expensive to provide than the hospital care. And so we were looking to figure out, how do we determine to be able to provide that care in the most cost-effective setting? The ROI comes because we currently have in our prize challenge, which is a $3 million prize, 1,300 teams competing. I think there's approximately 5,000 individuals that make up these teams from all across all industries, all universities. Most well-known academic universities in the world have teams competing in this. Certainly nothing that we would ever be able to utilize as a resource if we simply tried to hire everyone to come up with an algorithm. I think everyone up here would agree that that's one of the biggest benefits you get from a prize, is a whole new bunch of brains that are going to work on your problem, something you could never do outside the prize context. Second, and even more importantly, was we wanted to open up the world of healthcare and healthcare data and healthcare data solutions to an entirely new universe of individuals. We see that the best and the brightest, although not entirely, but to a large extent, are going to work at Goldman Sachs, they're going to work for a hedge fund, they're going to work for Google, they're trying to figure out how to tell you, figure out in the supermarket which brand of diapers you're most likely to buy so you get a coupon when you go down the diaper aisle. Why can't those people solve real-world problems such as predicting who's going to go to the hospital? So the goal of this, and the real reason we put the big number around the prize, was not so much because we figured there's a $3 million return for us on the avoidable hospitalization, but to get some notice to the problem so we could get those people involved and get them thinking about this world of healthcare data. Because healthcare data needs these creative young minds to come in and solve these problems. And putting a prize around something really can get people thinking about your competition or your problem that would not have been thinking about the problem other than for the prize. The design of the prize was actually far more complicated than we ever imagined. We're a healthcare company. We provide healthcare to people. We're not data miners. We don't do data all the time. It's not our background. I'm a lawyer. I mean, lawyers hate numbers. I don't really hate numbers, but it's certainly not my background coming up with algorithms. So it took us probably 6 months to put this prize together. We wound up using an outside entity called Kaggle, which specializes in running data prizes specifically, because this was not a judged prize. This is whoever has the best algorithm at the end of the day is going to win the prize. So we had to come up with a platform that would allow for the automatic judging of these algorithms that are submitted by the teams. The teams could submit an algorithm a day. With the 1,300 teams, you're getting a ton of algorithms, coming up with both the platform to run the prize, the design of the prize, as well as anonymizing the data, the records for 100,000 patients over a 4-year period, proved to be much more complicated and expensive than we initially anticipated. We spent a large sum on putting this prize together because of the data anonymization, the need for prize design, as well as time cleaning the data so it could be usable. We didn't do 100% cleaning because we wanted people to work with data that was somewhat real world, but healthcare data in general is very messy, and putting it in a you know, we had men who were in the hospital for 30 days because they gave birth to a baby. Now, obviously, that's the kind of stuff that is wrong, easy to tell, but there's plenty of stuff in there that people are not necessarily going to be able to tell because it doesn't stand out. We had to clean a lot of that up, and it took a lot of time. Then, finally, I want to leave you with some of the complications that we encountered and kinds of things to think about as you're designing a prize. One of the things we gained by the use of Kaggle, which actually made our job, I think, much simpler, was we had a built-in data community. There are people who, some of us play fantasy football and some of us play rotisserie baseball, and there's people who enter data contests.
Guilty as charged.
I hope you're in our contest. And Kaggle has probably 2,000, individuals, teams that do nothing but, well, they have jobs, but they also enter data contests. And these are some of the best data miners out there. By using Kaggle, we had this built-in infrastructure of teams that wanted to compete in our contest. That solved one of the problems, which was really getting the buy-in from the participant community, although the $3 million prize definitely helped in that regard. Another issue that we had to face was the privacy issue. Healthcare data has a whole host of advocacy groups surrounding the privacy community. We bent over backwards, making sure, both because we absolutely had to comply with HIPAA and because as a private company, if there was a data breach, would be absolutely catastrophic. So we bent over backwards to make sure that that could not happen. We hired 2 very, very well-known data anonymizers to work with our data. We tested the re-identification possibilities, and we had to make sure that there was no possibility of privacy breaches, both because it simply could not be allowed to happen, but second, so that we could address the concerns of the privacy community up front, because we knew they would be raised, and they were. Third, one of the other issues that came up that was totally unanticipated was the public concern that you're only doing this because you want to have a way to better adjust insurance rates. You want to know who's going to go to the hospital so you can make them pay more for their insurance. Now, we had I had not even considered that to be a concern. I anticipated the privacy concern, and I anticipated some of the other concerns, but I had never anticipated that concerns. That was really a public relations issue, because when someone understood the prize, it was not to, it actually would reduce costs. If we could identify those people who would go to the hospital, we could provide preventive care, and we could stop the hospitalization, which would actually lower costs. That went part of the way towards explaining what we were, why we were doing this. The other thing that we did was, as a matter of fact, we had to decide that we would keep the IP that was created through this for ourselves and to share with those who we thought would use it appropriately. We were concerned, and what we had to tell everyone was, we will not share this with insurance companies, so it cannot be used to rate populations for insurance sales, because we don't sell an insurance product. We simply provide the care to the population. So for us, it's not a concern, and we had to convince everyone that it would not be used improperly. Finally, and probably I should have anticipated it, although I did not, was the esoteric, somewhat concern of the provider community that was concerned we were going to be replacing doctors with computers. Because if you talk to doctors, and anyone who's worked with doctors extensively knows, people think doctoring is an art. And there is a lot of art to doctoring, without question. However, there are also things that computers do better than human beings right now. And we had to convince the doctors that we were going to be using the computers to supplement their art ability as a doctor, to help them provide better care to their patient populations, better preventive care, so that those patients would stay healthier. We succeeded in doing that, but it did take some work to convince the providers that we were not out seeking to replace them. So it's those kinds of things you really need to think about, because we think, wow, this is a great idea, it's a lot of fun, and it's going to improve the healthcare system in this way. sit down and think about who's going to be concerned by what you're doing, and talk to different interest groups, talk to different people who might be looking at your problem in a different way, so you can anticipate some of these things and kind of build in the answers into the way you set the problem up.
Jonathan, thank you. You made a tremendous, excellent point throughout your talk, but that one just now about not anticipating that cultural backlash from the physicians. So we talk about the inherent importance of getting all your stakeholders involved, getting them at the table early so they're educated, well-informed, they understand the intent. They can still disagree with you, but at least they're not walking around with this false perception of what you're trying to accomplish. So that's a great lesson learned. What's interesting is similarly, and I'm sure across the panel, you could talk about experiences like that where your scientists or physicians really were threatened by it. And you had to say, no, this is going to make your work better. I'm going to use your time more efficiently. I'm going to give you better raw data, better raw elements to work with, rather than you having to sift through all the patients maybe you shouldn't have been seeing for one reason or another. Something that occurred to me, though, that I thought you might have in common with Greg, he had an issue where they found a predictive correlate, but it was unactionable. How are you going to make the data you find, say, actionable? Like, 'cause how are you going to get this patient to comply with going to preventive care or compliance with treating your type 2 diabetes? So do you guys have any kind of thought process around the implementation of these data that you're going to have?
Yeah, the hope would be, and I say hope because one of the toughest issues in healthcare is compliance. Really getting that engagement with the patient population is an incredibly tough issue. The hope is that when you tell a patient vaguely that you shouldn't be doing this because you're going to be healthier if you do something else, it's almost too vague to change behavior. But if we can tell a patient that based on our algorithm, not us, their doctor, their primary care physician who sees them hopefully at least once a year, that the algorithm we've created tells us that you have a likelihood of being hospitalized in the coming year, but we have steps we can take in the interim to make that hopefully not happen, we think that's a much stronger message that will drive the compliance if it's sold in that way.
Excellent. A real tangible consequence they would have to deal with. So I'm going to have to close out the panel. We're almost 5 minutes over. We obviously have a lot of follow-on topics for our next workshop or conversation during the network period. We haven't talked about the built-in solver networks that come with some of these platforms, the pros and cons of that. It is a well-defined population. They are an engaged workforce, but they're not everybody. So how do you manage it? They're great resources. We use them all the time, but you just need to understand it, being fully knowledgeable when you walk in. I think the other issue that was brought up at the end there was IP issues. There's some great reasons to hold the IP. There's other reasons to exclusively license it and really foster development in the commercial space of whatever solution. So I want to give a round of applause to the panel. It was a great opportunity to hear their lessons learned.